Okay? So very first thing that I taught you guys in class was all about the fundamental counting principle. That's exactly what this question is. So it says a popular brand of pen is available in 6 colors and 5 writing tips. How many different choices of pens do you have with this brand? Remember when we talked about the fundamental counting principle versus permutations and combinations? Permutations and combinations, you're really dealing with one group of items. Like I'm dealing with students, or I'm dealing with faculty members, or I'm dealing with people in a race. You can see in this one, you're dealing with 2 different items. You're talking about colors, and you're talking about the writing tips. So since this is the fundamental counting principle, you multiply your options together. That's right. So we're going to take 6 times the 5, and what do we get? 30. 30 different pen choices. So all you do with the fundamental counting principle is take all of your options, multiply them together. Okay? Any questions so far? All right. For the fundamental counting principle, yes. Take your option 1, which is about colors, multiply that by your option 2, which is your writing tips. Because remember, these first 3 sections, 11.1, 11.2, and 11.3, were all about finding the total number of outcomes, because we use that in probability. So in this one, it says an ice cream store sells 2 drinks in 3 sizes and 3 flavors. In how many ways can a customer order a drink? Or that should be drink. Either way, it's all the same. So what are we dealing with here? It is going to be multiplication of all the ideas, right? So who is that specifically? It's your fundamental counting principle. Fundamental counting principle. Again, because you're dealing with different options here, different items. So we're going to take 2 times 3 times 3, and what do we get? Come back. Come on, you. 18? Okay. So there are 18 different drinks and sizes and flavors that you can mix and match together. Okay? All right. Let's go ahead and get rid of that little screen. So, question 3. It says a person can order a new car with a choice of 11 possible colors, with or without air conditioning, with or without automatic transmission, with or without power windows, and with or without a CD player. And how many different ways can a new car be ordered with regard to these options? So what are we dealing with here? So still more fundamental counting principles. That's right. So things in this one that you got to be careful of, there really are different options here. You've got your colors, with or without. So that's 2 options for air conditioning, with air conditioning, without. I don't know why you want to go without air conditioning. With or without automatic transmission. So that's another 2 options. With or without power windows. Again, another 2 options. And with or without a CD player. So again, that's another set of options. 176. You are. Make sure you guys. You can sit there. And Fabiola, you can come closer, girl. We got a room right over here. Feel free. So, just like what Brandon said, we're going to take 11 times 2 times 2 times 2 times 2. Because the 11 represents the colors. The first 2 is the air condition. The second 2 is the transmission. The third 2 is the power windows. The fourth 2 is the CD. Again, this is still that fundamental counting principle because we have different items we're choosing from. And Brandon, you said, what was the answer again? 176 different new car options. Okay? So question 4. So it says, whoa, my bad. It says you need to arrange 8 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that order of the books makes a difference to you? So what are we talking about here? This is your permutation, because order matters to you. Remember, with permutations, we talked about that order matters in a permutation. So remember, we're filling in this NPR, so this was a permutation. So notice now we're into 11.2, because 11.2 was all about permutations. So remember, N represents the total. How many books do we have total? 8. And how many books are we arranging? 8. So you go straight into your calculator and you run this information. You did it as a factorial. You can run it as the factorial formula. Remember, the factorial formula would be n factorial divided by n minus r factorial. That's the permutation formula. There you go. So there are 40,320 different ways we can arrange our books. Yes, you get the same thing by doing the factorial. Yeah, just be careful about that, because it doesn't always work that way. Okay? Yeah, because you're dealing with the same values. Absolutely. Okay? Any question on that? Calculator runs our information for that guy. All right, question number 5. I want to check something real quick. Good, we have our TI Smart View, because I want to bring that up too. So in our calculator, since we're going to be using that, you're going to want to use it. There's no way of getting through this test with, well, you can get through this test without using it. But why would you want to do that to yourself? So we're going to say it again. I guess. So, and then we'll clear out the key history. So where was the permutations on this? Let's review that real quick. Where do we go for permutations? Or if we want to do the factorial, like Brandon said, because we do need to know where those are. Math. Come on, you. Math. And then scroll over to probability. And number 2. And number 3 we'll use, and number 4 we will use. That's the factorial. Number 4 is what Brandon was talking about. All right. So if we ran this, all you'd have to do is go back and put in your 8. Oops, too far. And your 8 and hit enter. And there's that value that we came up with. All right. So let's jump back into our notebook. So it says a club with 7 members is to choose 3 different officers: president, vice president, and secretary treasurer. If each office is to be held by one person and no person can hold more than one office, in how many ways can those offices be filled? What are we dealing with here? This is a permutation, right? Because we are ranking our people. We want the best person, then the president, the best person, then the second best person as the vice president, and then our secretary and treasurer. So again, this is that permutation coming at us. So we're going to run that NPR again. So how many people do we have? 7. We have 7 members, and we are picking 3 officers. So you can't just do the factorial on this one. That's not going to work. You actually have to run the NPR from the calculator. And what do you get? 210 different ways to fill the offices. Any questions so far? Okay. Numero 6 says how many distinct permutations, so we know this is a permutation, can be formed using the letters of the word committee. Now, yes, this is a permutation, but can I use the NPR on this one? No. Why?
All the letters, and you got to find the factorials for all the repeating letters.
The repeating. There you go. Yeah, this is the duplicate permutation formula that we have to run. So this is a permutation, but it's all about the duplicates. Because we have letters that happen more than once. So remember when we're running this, the formula is n factorial over your p factorial, r factorial, q factorial, blah, 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 and it just keeps going. Remember all these guys down here on the bottom, these are the duplicates. The stuff that repeats in the problem. So you can't just run NPR on this, it won't work. So the first things first, what's your n? There are 9. Yeah. So 9 factorial. That's a weird looking 9. Let's fix it real quick. So 9 factorial divided by, well, does the C repeat? Does the O repeat? Does the M? How many M's? So that's 2 factorial. Does the I repeat? Does the T? Okay, so the T repeats, which means there's 2 factorial, and the E repeats. So another factorial of 2. So you definitely got to go to your calculator and run this, or you can run it by hand, I mean, if you really wanted to, but I wouldn't. So again, in our calculator, remember, we can make this look like a fraction. How do I make it look like a fraction? Alpha y equals, there's your fraction keys. We're going to use the first guy. And then what are we putting on top? 9 factorial. Where do I find my factorial again? Math all the way over to probability. Scroll down to your factorial. There you go. And then down below, we put all of our 2 factorials. So 2 factorial. 2 factorial. Whoa, hit enter on me. Sorry. So I'll just go back down there and put one more. 2 math. Scroll over. Come on now. Too far. Factorial. And now we hit enter. So how many different ways can we do this? I love it. You guys are in sync. So, 45,360 different ways we could rearrange these letters. For real, for real. That's a no-joke number. That is all the different ways we can take this and make distinct permutations. I know, right? All right. Number 7. So it says an election ballot asks voters to select 6 city commissioners from a group of 23 candidates. And how many ways can this be done? What do you think we're dealing with here? This is a combination because we just want 6 city commissioners. So it's not, they're all doing the same job, so it's not like one of them is more important than the other. So we definitely now dived into 11.3, okay, because now we're talking about combinations. So this is NCR. And if you forgot the formula for it, it looks just like the permutation formula, just with an extra added bonus down on the bottom of an R factorial. So that's what the formula looks like if you really want to learn it formula-wise, or, again, just put it in a calculator, let it kick out the answer for you. What is our N? Which is what? 23, good. C, how many are we selected? So you go into your calculator and you run it. There you go. 100,947 different ways we could have 6 city commissioners. Again, we just go to our calculator and we let it run. So let's take a look at that real quick. So there are 23 city commissioners, or people that are vying for the job. We go under math, scroll to your probability, and then this time we want number 3. And then there are 6 positions. And there you go. Let the calculator do the dirty work for you. Okay, let's jump back in. So it says, to win the lotto. To win the lotto, one must correctly select 7 numbers from a collection of 50 numbers, 1 through 50. The order in which the selection is made does not matter. How many different selections are possible? So what is this? Combination. And also, again, a big hint for this one, it says the order does not matter. Okay? So we're going to run NCR. It is a really big number. So what is our N? What is our total? 50. We have 50 numbers to pick from. And 7 is our R because we're picking 7 numbers. Absolutely. So you go into your calculator, you put your 50, you hit math, you scroll over to probability. There you go. 99,884,400 different lotto tickets. That's why it's so tough to win the lotto. There's tons of possibilities, and you have to find the one possibility that gives you everything that you need. All right, feeling good on that? Okay. So number 9, looks like we're in probability, so that means we now have stepped into 11.4. Okay? So this one says we got a 12-sided die is rolled. The set of equally likely outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Find the probability of rolling a 7. So remember, probability is all about the number on top being what is your possible outcomes, how many can that happen, okay? How many ways can that happen? Over on the bottom, the total. So we want the probability of rolling a 7. So how many ways can we roll a 7? There's only one way. Either you roll a 7 or you don't. Out of how many possible outcomes are there? 12. And of course, in your exam, you will have to reduce this down. So just like the fraction feature we used before, you can always come in here and you hit alpha y equals, and you can test your fraction to make sure that it reduces. Hit enter, and yes, it is reduced form. So you can always reduce your fractions in the calculator. You hit alpha y equals, and then test your fraction. So this is a valid answer. That's the answer that we would be looking for. All right. So let's do another one. Again, you're going to have to make sure that you know a deck of cards. Make sure you know a deck of cards. So in this one it says you are dealt 1 card from a standard 52-card deck. Find the probability of being dealt a red card. So we want to be red. How many cards are red in a deck of cards? There are 26 of them that are red. Out of how many cards total? 52. Which reduces to what? 1/2. Perfect. Yeah, you go into your calculator and let the calculator reduce that 26 over 52 for you. Okay? Yeah. So to reduce your fraction, if you want it to look like the fraction, you hit alpha y equals, and then you put in your 26 over 52, and then you just hit enter. And there it goes. All right. So jumping to the next guy, number 11. So this is the one that throws a lot of people off because you got to make sure that you know what you're looking at because there's a lot of information here. So it says the table below shows the educational attainment of the country's population aged 25 and over. So this is all about people 25 years of age and over. Okay, so this information is expressed in millions. Great. Cool beans. So like males that have less than 4 years of high school, it says 12, so that would really represent like 12 million. All right, so what it wants us to do is it wants us to find the probability that a randomly selected citizen aged 25 or over was a man with 4 years of college or more. So we want the probability of 4 or more years of college for a man. So, there you go. You start at male, and then you go to where you are 4 years or more. And that's our top number, the 21, and then you're absolutely correct, Brandon. How many people were in the survey? 154. That's our total. And then, of course, reduce it. 3 over 22. Yeah, it is that simple. It also depends upon which section this is coming from. Sometimes, depending on the section, you'd be looking at only maybe the column of 4 years or more. And then so your total might be out of the 40. But in this one, it's just plain old probability. Well, now when you answer it, you got to make sure that you write down what they want. So if it says that there's a rounding to a certain decimal, then they obviously want the decimal. But if you don't see anything that says round or anything like that, they want the fraction.
That's why they say type an integer or fraction.
Yeah. Read that fine print. All right. So now we are moving into 11.5. This is where we take 11.1, 11.2, 11.3, and 11.4, and we put it all together. So they're going to give you situations that are either the fundamental counting principle, permutation, combination, and then they want you to find probability based off of that. So here we've got Simone, Tyrone, Katrina, Ian, Maria, Larry, Sarah, and Eduardo have all been invited to a dinner party. They arrive randomly, and each person arrives at different times. So what are we really dealing with here? This is the factorial, okay? But, and more specifically, for us, it really is the fundamental counting principle. Because it doesn't matter how your guests arrive, just the fact that they're coming, okay? All of them are going to come. So this is why it's really not a permutation. It's more the fundamental counting principle, which in the end really is a factorial for this situation that we're dealing with. Because how many people do we have coming? 8, right? 4, 5, 6, 7, 8. How many ways can the first person arrive? 8. Yep. Which is why this is a factorial, because you're looking at the definition of a factorial. You start at your highest number and you multiply all the numbers. 40,320? So there are 40,320 different ways these people can come to the party. Okay? But we're not done. They want to know how many ways can Simone arrive first and Eduardo arrive last. So what's that telling you about our first person? They're locked in. We don't worry about this piece. We already know who that's going to be. 5, 6, 7, 8. And what does that tell us about the last person? Also locked in. That has to be Eduardo. So how many people are we worried about between? 6 through 1, right? So there are 6 different ways the second person can arrive. There are 5 different ways the third person. 4, 3, 2, 1. This really is your fundamental counting principle. So what's 6 times 5 times 4 times 3 times 2 times 1? 720? Okay? So there are 720 different ways that we could have Simone arrive first, Eduardo arrive last. And then last but not least, they want the probability of this situation. The probability of the first and last. Well, how many ways can that happen with the first and the last?
1 over 56.
No, well, you're reducing too much. Answer the question first. How many ways can the first and the last go? 720. There's 720 ways this situation can fall out. With Simone first, Eduardo last. Out of how many? There you go. Out of the 40,320. And then you get, say it again? 1 over 56, because you go to your calculator and you let it reduce that down for you. And there's your probability. Everyone good so far? Okay. John, do you have a question? Sure.
The first one says the first one we have to multiply each everything.
Mm-hmm.
Then the second one you reduce the first one and the last one.
So we took out 2 people and they're arriving because we already know when they're going to happen, right? Mm-hmm. Yep. Last one, you take your answer from part B divided by your answer from part A. Because this is the situation we care about in part B, and in part A is your total. Okay? Good question. All right, 13. So this says a group consists of 7 men and 6 women. 4 people are selected to attend a conference. What are we talking about here? This is a combination. I don't care who's going to the conference. I just need 4 of you to go. So this is definitely a combination. So everything we run from here is a combination. So the first thing says, in how many ways can 4 people be selected from this group of 13? So what are we going to do there? 13C4. And you go to your calculator, you run that, and you said 713? Or 15? Yeah. 715. So there are 715 ways I can select 4 people to go to this conference. Okay? Now, down here it says, in how many ways can 4 women be selected? 15? And how'd you get that?
With the combination of 6 and 4.
6 and 4? So 6C4, because there are 6 women total, and I'm choosing 4 of them, and you said it's 15? Okay? And then in the end, we want to know the probability of nothing but women, which is the 15 over the 715. Absolutely. Because there are 15 ways to have all women and 715 ways to choose everybody. And that reduces to, whoa. Yeah, absolutely right. 3 over 143. I know. Okay? Again, you had to run 2 combinations to get the numbers you needed, and then you just compare the 2 over each other. And reduce. Okay? All right. So now we are out of 11.5. Now we are jumping into 11.6. So this is where we start to hit up those complement ideas. This is where we start to hit up and or situations. So that was everything that came from 11.6. Now I also believe we have odds in here as well. So here it says, you are dealt 1 card from a deck of 52 cards. Find the probability that you are not dealt a 6. So remember we talked about this, that there are 2 ways to think about this. You can do it the logical way. Well, we don't want a 6, right? So how many cards are not a 6? How many cards are not a 6? No, there are 4 cards that are a 6. There are 48. So if you take that 52 minus 4, you get 48. Out of how many cards? 52. And then you just go into your calculator and you let it reduce the fraction. 12 over 13. Okay. If you take 52 minus 4, you get the 48. Some people aren't used to cards, Brandon. There's 4 of every number in every picture card. They go from ace to 10, and then there are 3 picture cards, your jack, your king, and your queen. And there are 4 of each because there are 4 suits. The other way to think about this is you can think about it as a complement. If you want to get the probability of no 6, then take 1 minus the probability of actually getting a 6. So what's the probability of actually being a 6? Well, there are 4 cards that are 6 out of 52. So if you go into your calculator and you take 1 minus 4 out of 52, it'll reduce it down to that 12/13. So again, there are 2 ways to think about it. Logical way, this is what I did for the top, and then this is what we call the complement way. Everyone good? Okay. All right, so it says you randomly select 1 card from a 52-card deck. Find the probability of selecting a 3 or a 10. So we're at the probability of a 3 or a 10. Okay, hold on. Before you start diving into this probability, right here, this is a huge word for us, or. Remember, when it comes to an or situation, you have to ask yourself 1 question first. What is that question? That's for an and. You're going to ask yourself if you're and, independent or dependent. But what do we ask ourselves for an or?
Basically, it's like if one of them, like let's just say if you have,
Can you do one without the other?
Say it again. Can you do, so I like where you're going, but it's, can they happen at the same time? This is what we call mutually exclusive or not. You need to ask yourself if you are mutually exclusive or not. Now remember, mutually exclusive means they cannot happen at the same time. Cannot happen at the same time. Okay? Yeah, like a TA. Can you be both a teacher's assistant and a professor at the same time? No, you're one or the other. Okay? We'll get to that guy.
Yeah.
All right, So in this case, in other words, can I be dealt a card that is both 3 and 10? No. No. You can't get one card that is both of those. You get a 3 or you get a 10. So this is what we call mutually exclusive. This is what we call mutually exclusive because you can't be both of these at the same time. So in that case, all you're going to do is find the probability of a 3 and add it with the probability of a 10. So what is the probability of a 3? 4 out of 52. Because there are 4 3s. Come back. I like to act so weird sometimes. Because there are 4 3s out of 52 cards. How many 10s are there? 4 out of 52. And then you just go to your calculator and you let it do the fractions. You put in your first fraction, 4 over 52, plus your second fraction, 4 out of 52, and then get your answer. Yes, you can reduce these before you do it, but just put it in the way it is and then let the calculator reduce it all in the end for you. So what do we get? Say it again. 2 over 13. Yes, Brandon, we do get the 8 over 52, but remember that reduces to 2 over 13. I just go straight to the reduced answer because, again, I let my calculator do all that work for me. So I don't hit the middle guy, which is 8 over 52, and then reduce that. I just say in my calculator, 4 over 52 plus 4 over 52. Oh, calculator says it's 213. All right, 16. So this is the one that Brandon mentioned a moment ago. It says the mathematics department of a college has 12 male professors, 10 female professors, 14 male teaching assistants, and 6 female teaching assistants. If a person is selected at random from the group, find the probability that the selected person is a teaching assistant or female. So again, this is an or. We want the probability of being a TA or female. So again, you ask yourself the question, are these mutually exclusive? No. Because is it possible to be female and a TA? Absolutely. You can see it right up here. It says 6 female teaching assistants. So in this case, what you're going to do is you're going to find the probability of being a TA. We're going to add that with the probability of being female. But because these are not mutually exclusive, you're going to subtract off the probability of being a TA and female. So that's how this probability works when you're not mutually exclusive. You have to subtract off the probability of when they both occur. So what is the probability of being a TA? 20 out of how many? 42. The 20 came from taking all my teaching assistants and adding them up. 4 plus 6 is 20. The 42 came from adding up all of your numbers. Take 12 plus 10 plus 14 plus 6. That's where the 42 came from. Okay? So what is the probability of being female? Well, how many females are there? Careful, there are more than 6. 16 out of how much? Oh, here we go. Every now and then it likes to stop. Give me just a moment. We were on question 16. Jumping over to that. All right, so you said that there are 16 females. Out of how many? 42. And again, there's 16 because we have 6 females there and 10 female professors. And then last but not least, we're going to knock out how many positions are female and teaching assistants. There are 6 of them. So we're going to subtract off 6 out of 42. And again, I'm just going to go to my calculator. I'm going to put these 3 fractions in and let it do the work for me. I'll put 20 out of 42 plus 16 out of 42 minus 6 out of 42. And it's going to kick out an answer of what? 5 over 7. Come on, you. There we go. Okay? I don't know why I didn't put not mutually exclusive on that. Okay. So 17, odds. Odds. So we're still in 11.6. No, 11.5 still, because odds is in 11.5. So it says, one card is randomly selected from a deck of cards. Find the odds in favor of drawing a heart. So we want the odds of drawing a heart. Well, remember odds, the top number is what we want. So how many cards are a heart? Say it again. There are 13 hearts. Because you have the ace, the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen. That's 13 cards. Now on the bottom, it's not a total, or the number beside it, it's not a total. This is not out of 52. The other number represents how many cards are not a heart. So how many cards are not a heart? 39? And you are correct. Because you just take 52 minus the 13, you get 39. And as always, you need to reduce your odds. It's just like reducing a fraction. It's just like reducing a fraction. Take 13 over 39 in your calculator. What does it reduce to?
Apply to the space and ace.
This includes aces that are not a heart. Okay? Aces, in our book, they really refer to aces as the number 1. Okay? So there are 39 cards that are not a heart. Because you have 13 cards in the clubs, you have 13 cards in the spades, and you have 13 cards in the diamonds. That's 39. So, but what does this reduce to? No. No.
Oh, sorry, I was doing this one. Sorry.
Not this one.
1 and 3.
1 and 3. That's all we need. That's the odds. Got a 1 in 3 chance.
Next one was 25.
And we'll get to that.
Well, that's already said it, but both the first one.
I know. Spoiler alert. So this time it says one card is randomly selected from a deck of cards. Find the odds against drawing a black ace. Find the odds against drawing a black ace. Did I make these questions? No. Computer generates this for me. I know. So if you don't know cards, again, get out there and look at least all of them are not about cards. There's only a couple. So we are against a black ace. So against. When we're against, that changes things up. So in the last guy, I probably should have put it on there. In the last guy, we were in favor of this.
In favor of the smaller numbers goes first.
Very good observation, Brandon. Yeah, when you're in favor, the smaller number goes first. The larger number is usually your second guy. Against is the opposite. So in here, since we are against a black ace, I need all the cards that are not a black ace. There's 50. Because there are only 2 black aces. Ace of spades, ace of clubs. So 52 minus 2 is 50. So there are 50 cards that are not a black ace. How many cards are a black ace? Because that's the second number. 2.
So it reduces 25 to 1.
25 to 1. Again, it reduces just like a fraction. 50 over 2, put it in your calculator, and it reduces to 25 over 1. All right. Jumping into the next guy. Fill this out for me. And then also know that I will be posting this in Canvas as soon as we're done. Okay? So this time it says a single die is rolled twice. Find the probability of rolling an odd number first and then a number greater than 4 the second time. So we want the probability of being odd and greater than 4. So this is 11.6 because we're hitting up ands. This is 11.6. So what was the question you have to ask yourself about ands? And we talked about it earlier. You got to ask yourself what before you can do anything. Not mutually exclusive.
I said the word earlier.
You said the word earlier.
Oh, God, that's embarrassing. Are they independent or dependent?
Independent or dependent. So remember with this, independent means that the first outcome does not affect the second outcome. To be dependent, the first outcome will affect the second outcome. Most of the time when we talk about this in class, if you are independent, that's kind of like with replacement. You're putting something back in there because everybody will then have the same chances over and over again. Without replacement leads to dependent because when you do not replace that, now it's not the same for everybody that comes afterwards. So the question is, does the first roll, will that affect the outcome of the second roll? No. No, the first roll has no bearing on the second roll. So these are independent. No. Would be like with replacement, yes. But in this case, there's no replacement. We're just, the first roll doesn't affect the second roll. Okay? So since that is true, it's independent, all we have to do then is find the probability of being odd. And this time we will multiply that with the probability of being greater than 4. So, on a single die, how many numbers are odd? 3. Out of how many possible outcomes? Good. Times, how many numbers are greater than 4? 2. That's 5 and 6. So there are 2 outcomes out of how many? So there's your 2 probabilities. You go to your calculator, you multiply this stuff out, and it will kick out the answer for you. So what is 3, 6 times 2, 6? Now that's not 6 over 6. 6 over 36, which reduces to what? 1 over 6. So again, you just let the calculator do the dirty work for you. Remember, when you multiply fractions, if you're doing this by hand, which I don't know why you would, but you multiply across the top, you multiply across the bottom. So 3 times 2 is 6, 6 times 6 is 36, and 6 out of 36 reduces to 1/6. John? The 3 and the 2. All right, so remember that these are the outcomes. 1, 2, 3, 4, 5, 6. So the first probably says, how many of them are odd? So, no, there's not 6 odd numbers up here. There's only 3. 1, 3, and 5. So that's where the 3 out of 6 came from. There are 3 odds out of 6 possible outcomes. The next guy says, how many numbers are greater than 4? 5 and 6. So that's 2 out of 6. Okay? So that's where those come from. All right. Oh, Fabiola. Mm-hmm.
How come in this one we multiply the denominator, but in there was a previous question
In the adding and subtracting, you leave the denominator alone. Remember, when you add and subtract fractions, you only deal with the numerator. The denominator stays. Okay? But again, remember, you let your calculator worry about that. Some of you are worried a little bit too much about how do we add, subtract, and multiply fractions. If you're doing this by hand, you're going against what I told you to do. Just let that calculator run it for you, okay? Because that's where some of you are getting confused on those rules, and you're forgetting what to do, and that's going to lead you to a wrong answer when you can just use your calculator to get you to that right answer once and for all. But when you add and subtract fractions, you leave the denominator alone, okay? As long as they're common. If they're not common denominators, then you need to get those common denominators. But again, I'm not going in that because that's not what this class is about. Okay? But when you multiply fractions, you go across the top, and you have to go across the denominator. Okay? So you multiply the top and the bottom across. All right. So it says you draw 1 card from a 52-card deck. Then the card is replaced in the deck, and the deck is shuffled, and you draw again. Find the probability of drawing a 9 the first time and a heart the second time. So we want the probability of a 9 and a heart. So again, you have to ask yourself, are these independent or dependent? Why did you say dependent? But you're missing the key word in here. You're thinking mutually exclusive. Yes, I can have a 9 of hearts, but that's mutually exclusive. I'm asking, are these independent or dependent? Meaning, does the first outcome, will it affect the second outcome? And the word I boxed in is the key in this. I'm going to put that card back. So when I draw the first time, how many cards will I have? There are 52, right? When I replace it, and I draw the second time, how many cards do I have? 52. It's still the same, right? So I did not affect the second outcome. So these are independent of each other. I agree that they are not mutually exclusive, but that's not what we're dealing with in this case. We're dealing with an and. So ands are all about whether they're independent or dependent. Does that make sense, Elizabeth?
So when we're dealing with ants, is always going to be independent?
No, not always. It could be independent or dependent. You'll see one of those soon enough. Okay? So, again, in this, since they're independent, all we need to know is the probability of drawing a 9, and we're going to multiply that by the probability of being a heart. So what is the probability of a 9? How many 9s are there in a deck of cards?
4.
4 out of how many?
52.
Okay. And then over here, how many hearts are there? 13 out of 52. So go into your calculator, let it do the work. Put in the fraction 9 out of 50 or 4 out of 52. Multiply that with the fraction of 13 out of 52, and it will reduce everything for you.
Nine over 208.
Say it again?
9 over 208.
Mm-mm.
I got more.
1 over 52. Let me see.
The calculator's not auto-reduce, I guess, then?
You put 9 over 52. It should be a 4 over 52. I accidentally said 9, so I can see why you did that. But that's a 4. Careful what you put in, John. Any question on this one? Okay. So here it says Elizabeth, thank you, Elizabeth, brought a box of donuts to share. There are 2 dozen donuts, which means that's 24. Okay, if you don't know what a dozen is, it's not a baker dozen. Okay, in a box, all identical in shape, size, and color. 2 are jelly filled, 6 are lemon filled, 16 are custard filled. You randomly select 1 donut, eat it, and then select another donut. Find the probability of selecting a lemon-filled donut, followed by a custard-filled donut. So we want the probability of being a lemon and then a custard. So are these independent or dependent? This is dependent because we're not, once I ate it, it's not coming back out. Okay? We are not regurgitating the donut back into the box just so we can have 24 again. Okay? So this is dependent. So John, you asked, are they always independent? No. It depends on the situation. So, yeah. You got to look at the situation. So this is because we eat it, that is without replacement in disguise. Since we're eating it, we're not putting it back. So this time, what we need to do when we think about this, first we're going to find the probability of being lemon-filled, and then we're going to multiply that by the probability of being custard after a lemon has come out. All right, slow down, Brandon. Slow down. Yes, we're going to get to that. So just give it a second for people to digest. So the probability of being a lemon, Brandon, you said was 6 out of what? 24. Now, the next guy. Because we ate the donut, how many donuts are left? 23. So you see why this is dependent, because it's not the same box anymore. And there are 16 custard filled. Yeah, if we ate a custard filled first, and then another custard, then the second guy would have been 15. Yeah. So in the end, you just go to your calculator, you put 6 over 24 times 16 over 23, and it reduces to 4 over 23. Perfect. Everyone good so far? That's me.
So I'm still trying to figure out how to do the reducing kind of.
Alpha y equals. So your calculator doesn't have that ability. You need to get your calculator's iOS updated. Or not iOS, just the operating system updated. And they can do that here in the Plaza if you just go and ask them. Okay? All right, 22. So we got this chart again. Although instead of being colleges and your education, now we're talking about whether you're married, divorced, widowed, all that stuff. So in this one, again, when you're looking at this, if you think to yourselves and look at the probabilities that they're asking, it's an or question. So again, when you're or, what are you looking for?
Looking for 2 options they add together.
What's the question you got to ask yourself?
Oh, are they mutually exclusive?
Mutually exclusive or not? So, and again, we talked about this in class. The current status is the status you choose. You cannot be more than one status. Okay? So again, I always use myself as an example. I have been divorced, but I am now remarried. So I have to follow under the status of married. Even though I've been divorced before, whenever I fill out an application, I always say I'm married. Okay? So you can't be more than one status. So in the case of this or, these are definitely mutually exclusive because you can't be more than one status.
If there was a thing that was married, remarried, or divorced, when you have to, and two of them were the remarried and divorced, and you have to subtract some from the remarried then, in that case?
Hold on. Say that again?
Let's say there instead of this question was married, remarried, and just divorced, as in you got divorced but you never got married again. You have to subtract some remarried from the divorce.
That's a good question. Although I would have to have another column up here for the remarried people. And my gut instinct is to be like, no, because the divorce just means that you are divorced. Again, remember I said you can't be more than one category.
Fair enough. I was asking out of curiosity.
Good question, but no, and you're not going to do that, and I'm not going to throw anything at you like that. That would just be plain mean. So on this one, again, there are two answers. They want it as a fraction and as a decimal. Whoa. So they want it as a fraction and as the decimal. So the first things first, since these are mutually exclusive, all we need to do is find the probability of being widowed, and we're going to add that with the probability of being divorced. So how many people are widowed? There are 13 total. Out of how many total? 244. So 13 out of 244. Plus, how many people are divorced? There are 27. Out of how many total? 244 again. 27, 244. And you let the calculator do the work for you. And what do we get for the fraction? No?
I got it. 10 over 61.
10 out of 61. Got to reduce. 10 over 61. So that's answer number one. And then all you're going to do is you're going to go back into your calculator and you're going to divide these two numbers and give me the decimal to the nearest hundredth. The decimal to this to the nearest hundredth. Hundredth. How many decimal places is hundredth? 2. So what do you get? 0.16. So those are the two answers they're looking for. Okay? Go on your calculator, take 10 divided by 61, and make sure you round accordingly. All right. So right here, that now cuts us off and leads us into the next chapter, chapter 12. So that's everything you need to know from chapter 11. So from here on out, we're in chapter 12. So here, this is that multiple choice question. So it says the government of a large city needs to determine whether the city's residents will support the building of a new middle school. The government decides to conduct a survey of a sample of the city's residents. Which of the following procedures would be the most appropriate for obtaining a sample of the city's residents? So, should we random sample of adults who currently have children in public schools? Should we survey every fourth person that goes into a local nightclub? Should we survey the last 100 residents of a telephone book? Or should we random sample of persons within each neighborhood? The last one, yeah. The last one. Because again, you need to survey everybody, all your constituents that might be involved in this process, which means that we need to hear from everyone. If you just survey those that have children in public schools, well, you're missing out on some people. You could be missing out on those in a charter school, those in a private charter school, those that don't have kids in the school, but maybe they're in their areas where that middle school is going to go. So that's going to affect them. So you definitely want to talk to everybody that's possible. Going to a local nightclub, most likely those are younger students of a college or things like that. They're not going to care one way or another about a new middle school. And obviously the last 100 residents of a telephone directory, that would throw me out of the equation, being that my last name is Armstrong, so I wouldn't get to have a say. So I wouldn't like that at all. So it has to be D, because, and I also have kids, so, I would want to, a say in it. So definitely D, talking within each neighborhood is the best outcome for that. All right. 24. So we talked about this in class, that all you're doing for the frequency table is you're just putting tallies for all the numbers and where they go. And then in the end, you're just going to count up the number of tallies. So for this information, you just start with your beginning number, 23, and I'm going to put a tally in that box, cross it off. And then I got a tally in 19, cross it off. I got a tally in 24, cross it off. 15, 21, and you keep going in this fashion till you have done every number, and you've tallied every number. And as your tally table goes, it will look like this. Kind of speed things up for us. There are 2 tallies in here, so the frequency for 15 is 2. 16 looks like that, so what's the frequency? Oh, you guys are all doing it real quick. Very studious of you. So I'll put in mine, and you can double check yours. So you can double check your tallies against mine once you've kind of gone through and gotten everybody. Those of you that are watching this as a video, you could have paused it at the very beginning, gotten your tallies, and then double checked it. So then we just start totaling things up. So what is the frequency for 16? I got 3 though. 3. What is the frequency for 17? 0. 18. 4. 19. 3. 20. 2. 21. Okay. 22. 23. 24. And 25. Again, if you add all these numbers up, you can double check yourself, because there should have been a total of 30 college students. And if you add all those numbers up that I just gave you, it will come out to 30. 25 is a lot like what we just did. Although in this case, they're giving you a range. Nope. This is simply you working with your table. No calculator work on this guy. I mean, if you wanted to, you could, and then put them in order. Yeah. We'll get one. We'll get to those. So here, again, you're doing a tally table, but you're going to take each one of these numbers, and you're going to put them in where the range that they belong into. So, again, you just start at the beginning, and in the end, you should have, well, it doesn't say how many there are total, but in the end, if you just count up all your numbers, that's how many you should have total in your frequency once you add up all those numbers. So I start with 69, and 69 goes right into the last category, cross it off. 57 goes right into 56 to 60. 52 goes into 51 to 55, and it's just like what we did right before this. 59 goes into 56 to 60, and you keep going. 69's down in here. So you're just putting your tallies where those numbers go. So go ahead and pause this if you want so you can do your tallies real quick, and then you can check with what I'm going to put up here in a second. So that's what your tally should look like. So what is our frequency for 41 to 45? 9. What is our frequency for 46 to 50? 7. And 51 to 55? 56 to 60? 14. 61 to 65? And 66 to 70. And there you go. Those will be the numbers that we're looking for. Okay? It's just filling in your tally table just like what we did before there. Any questions on this one? I know these next couple questions, they're going to make you do a little bit of writing and tallying and things like that. All right, so let's jump over to number 26. So number 26, they've already done the frequency table for us. And again, remember when we talked about this in class, this is all about just matching your graph or matching your frequency table to the graph. Matching your frequency table to the graph. So just start looking at some of those key points. I mean, obviously it's not going to be the first graph because it says 0 up in my frequency table is at 2. If I look at my first graph here at 0, there's no bar. Can't be, so this guy's out. Can't be the second graph over here at the top right because 0 is all the way up here at like 10 or 11. That doesn't make any sense. This graph right over here, well, that looks pretty good so far because in the bottom left, you can see that 0 probably is about 2 there. And if you check the last graph, just, you know, to see how things are going, again, 0 is just way too big again. So, yeah, it has to be this guy right here, the bottom left-hand graph. And I do on your final. I do on your final. But in this guy, I forgot to. So it is the bottom left-hand graph. I know. So then all you have to do for the next question that's right below this is find me a line graph that matches that information. So here's your frequency. So if we start looking across this, obviously it's not, if you look at the first guy, kind of looks like things are matching up. Kind of looks like 0 might be at 2 right there. So that's good. If we look over here, this could be a possibility. But if you look at everything that's going on in our frequency table up here, 2, 3, 4, then 20, then obviously you can see that right down here we don't even have a point up here at 20. So you got to throw out the second graph. And then, again, you look at this guy, 0 is still way too high, so you throw that guy out. And if you look at this guy, again, 0 right here, that's just way too high. These little bars over here represent 2s. So this is 2, then 4. So they're trying to say 0 is up at 4 there. So obviously you have to throw this guy out. So yes, it should be the first one. So you just look at those minute details.
To figure out number 26, we have to use stat to find out the stress gradient, the frequency.
That's already given to you. This table will already be given to you. You just have to match the picture to it. So you're not creating anything. That will already be given. So I asked to go over to the patterns again. So one thing you have to look at this. So you've got 4 bars in here, and then it's 10. So that means that your graph over here on the side, the y-axis for all these, they're counting by 2s. Okay? So if you look at this, we need 0 to be at 2. So if we look at our first graph, 0 right here, it's pretty much by that line too. So right here shows 0 of 2, right? Well, let's look at the other graphs. Here's 0. It's below the 2 mark. So is this graph making any sense? No, but when you also look at 3, 3 should be at 20. So when you look right here at the number 3, that's nowhere near 20. Does that make sense? Sorry, I actually went too low on that. 3 is actually right here. And that dot is nowhere near 20. If you go back and look at our first graph, here's 3. Oh, look at that dot. It's all the way up by 20. So I'm looking at the patterns here. So this guy right over here, here's 0. Where's my dot? It's all the way up there at 16. That don't make any sense. 0 is supposed to be at 2. So that's why we have to throw these 2 graphs. They're just not matching what's in my table. And if you look at the last guy, look at your, well, 0 here. 0's up at the second mark. That second mark is 4. But if you also look at what happened at 3, look at where 3's at. It's up above 20. And 3 is supposed to be at 20. So again, it's just making those observations about what you're seeing on your graph. Making sure that your graph matches the numbers that's in your table. Okay? All right, 27, a 2-parter again. Stem and leaf plot. So again, in class, we talked about this. All you're going to do is take your numbers and put the leaves where they go. Now remember, my first number is 64. So how do I make the leaf? Well, don't always think the middle. You knock off the, you knock off the last number. The last number is what becomes your leaf. So for 64, we're going to take the leaf of 4 and put it under the number 6. And then we're going to continue in that fashion. Kind of like a frequency table, but this time instead of tallies, you're putting numbers. So if I cut 41, cut the last number off, that means at the stem 4, I will have the number 1. So the question was, does this have to be in order? No, it doesn't have to be in order, but when you actually do a real stem and leaf plot, yes, it should be. But our book, they don't stress the order of your leaves. They just say, just give us the leaves, and in the order however you want. So 48, there is an 8 under the 4. No. So then at 49, we've got a 9. You do not have to put these in order. At 36, we'll have a 6 at 3. And I'll show you that it doesn't have to be in order. Just 1 second. At 5, we'll have a 3. Now look right here. At 4, we're going to put a 4, right? I'm going to put that right after the 9. Obviously, my numbers on the 4 are not in order. 1, 8, 9, 4. I don't count like that. So you keep going in that fashion. And then your leaves will look like this. If you want to pause and do this, you can do that, and then take a look at what I'm putting down. And they want you to put commas between your numbers. In a real sim and leaf plot, you do not put commas. That's bad. In a real one, you don't. But for their information, they want the comma between your numbers. 8, 6, 4, 5, 2, 8, 4, 6, 8, 6, 2, 9, 7, 4, 2, 9, 5, 2, 7, 7, 4, 9, 9, 9, 6, 3. So that's what your stem and leaf plot will look like. If you want to put the numbers in order, good for you. Cool. Do it. But they don't have to be. And then question B on this is just a multiple choice question about observations that you see in this problem. So question B is all about the observations that you see in this problem. So Brandon says it's C. So I do have question B up here. I'm just giving people time to write stuff down. So when you look at question B, which I'm going to talk about out loud, then I'll show it. They give you 4 options. They want to know which one of these talks about the shape of the display. So it says none of the college professors live to be 70 years old. If you are younger than 30, you cannot be a college professor. The greatest number of college professors are in their 40s. Or D, none of the above. So if we go into that question, based off of what we found up here, none of the college professors lived to be 70 years old. Well, we don't know if anybody died. I mean, we do have a college professor that is 69. So that doesn't mean that at 69 they're dying, okay, or they died. So we don't know about A. If you're younger than 30, you cannot be a college professor. Well, that's not true. We have professors that are younger than 30. The greatest number of college professors are in their 40s. Is that true? Absolutely, because that's where we have the most amount of numbers. So the answer is C, because obviously since we have C for an answer, you can't be D. I know, right? All right. Everyone feeling good? All right. We wouldn't have a lot of things that we know today without some of that information. All right. So 28 through basically number 33, these are all questions that I encourage you to use your calculator on, because the calculator will kick out all these answers for you. Although the numbers that they're giving us, there's not a lot of them, so you can do this without, going into the calculator. But I want to continue to show you that calculator use. So in this guy, it says find the mean. How do you find the mean of data?
Add them all up and then divide by how many there are.
Add them all up and then divide by however many there are. So you could add all 6 of these numbers up and then divide by 6 and get your answer, which, if you do add them all up, your top number ends up being 372 divided by 6 numbers. We're not on range or anything. We're on mean right now, Brandon. Okay? So if you take and divide this, you get an answer of 62. I'm going to show you how your calculator can help you out with this question and some of the other ones. So again, you can all do this by hand. You don't have to use a calculator, but again, you could also use a calculator to double check yourself. So that way you know that you have the right answer. So if we go into our calculator, where is it that I can put these numbers to help me figure stuff out? Under stat. And then where do I go from there? Go into edit. Right there at the very beginning, hit enter. And so in here we can put our numbers. And so I put them in order. So I got 61 for the first guy. Or excuse me, put them in order if I would actually do that correctly. It's 56 for the first guy. Then 61. But they don't have to be in order. Remember, they don't have to be in order. Because your calculator can put them in order for you if you wanted it to. 63, 64, and 67. So there's our 6 numbers. And now that they're in, where am I going to go to have it calculate that mean? Well, we're going to get to that, but where do I go then? Go back to stat and go where? Calculate. Oops, scroll over. And we want number 1. We want the statistics, one variable statistics, because there's only one column. So hit enter, and then hit enter 3 times. Yep. So once you're in your list, you've got your numbers, right? We want to do some calculating. So we're going to hit stat again, and you're going to scroll over to the word calculate. And you want the very first guy. So you hit enter, and then you got to hit enter 3 times. Come on, you. Where is the mean on here? The X bar right up at the top. This guy right here, that's the mean. Okay? Nope, SX is something else. What is the SX? That's the standard deviation. Okay? Let's also talk about what else you see on the screen. What does min X mean? Minimum, which means the smallest. That's your smallest value in that table. That's the smallest value. Notice that there's a little arrow right here. That means there's more information if you scroll down. What does med mean? That's the median. So right here, this gives you the median of your information. What does max mean? The most. Okay, the highest. Sorry, don't say most. The highest number. So min is your lowest value. Max is your highest value. Give me one moment. I need to change the batteries. Get off me, tape. All right. Hopefully this is picking back up and sound is still continuing. So this screen right here, when we did the one variable statistics, gives you lots of great information. It gives you the smallest number, the largest number, the median, the mean, and standard deviation. And all that information can help you get through these questions from 28 to 33. All right. So let's jump back into our piece. And so, we didn't check our mean. And so the mean that we came up with was 62. And so it checks out. This thing. All right, jumping over to number 29. So again, on this guy, we're looking for the median. I just showed you how this thing can find the median for you using your calculator. So you can use your calculator to do that. Or, again, in order to find the median, what does median mean? The middle. So you can take and put your numbers in order from least to greatest, and then count to the middle. What happens when you get stuck between two numbers? Add them and then divide by 2. So if you actually put these in order from least to greatest and work towards the middle, which from least to greatest, they look like this: 12, 13, 14, 14, 15, 16, 18, 19. So there are your numbers in order from least to greatest. If you start working towards the middle, so from 12 to 19, 13 to 18, 14 to 16, I get stuck between these two guys right here. So that's why I asked that question a moment ago. What happens when we're stuck? Add the two numbers and divide by 2. So what do we get when we take 14 plus 15 and divide by 2? 14.5. Nope. 14.5. Don't round that up, because those directions do not say to round. Tenth, but there's only one decimal place, so it's already there. Yeah. Okay? But again, you can go into your calculator and you can put these 8 numbers and then run that one variable statistic that I just showed you, and it will tell you the median, because remember, that's what that word med down at the bottom meant. So when I put them in the calculator, no, they do not have to be from least to greatest. So I can come back in here. So again, we want to change our list, right? So we're going to go under Edit. Now, since you have a list in here, you can go scroll right back up to the top, hit Clear, and hit Enter, and that takes the list out. So you scroll up to L1, hit Clear, hit Enter, and that will take the list out. You got to hit Enter once you hit Clear. All right, and then so we can go in and put in our numbers. And again, our numbers can be any order they want. So it can be like 18, then 16, then 12, and then 13, and then 14, and then 19, and then 14, and then I need a 15. So my numbers are definitely not in order, right? But if I run my statistics under Calculate, it still calculates everything that I need. See? Median 14.5. They don't have to be in order. All right, jumping back into our notes. Number 30. So this time it wants us to find the mode. What does mode mean? Find the number that happens the most. So in this case, you can't use the calculator for this guy. Well, I mean, you kind of can, because it'll put them in order, but all we're looking for is the number that happens the most. So it's 41. You can see it right here. Mode means most. And it's okay not to have a mode. It is possible to not have the mode. If everybody occurs the same amount, there's no mode. It is also possible to have more than one mode. But in our case, we don't have more than one mode. All we got is just 41. Mode means the most. Any questions on mode? Okay. Number 31. So 31, they want us to find the mid-range. Do you remember what the formula for mid-range was? Nope. The number that happens the most. So you got to be careful by saying just repeats, because I need the number that happens the most. In this case, the number that happens the most is 41, because there are 2 41s and everybody else, there's only one of them. Okay? Yeah, so just like what Brandon said, if there is another 40, then there are 2 modes, because 40 and 41 happen the same amount. But if there was another 40, then the mode is now 40, because that's the number that happens the most. Okay? It's not just about being that it repeats. All right, mid-range. How do we find it? Yep. Smallest entry plus the largest entry divided by 2. There you go. So in here, you can get the smallest entry and the largest entry. Again, you could go into your calculator and put these numbers in and have it sort it, and then you can find the lowest and the largest. Or you can run that one variable statistics, and remember min x and max x. That's the min, and the min x is the smallest entry. The max x is the largest, but you don't have to do that. I mean, hopefully we could use a little bit of common sense, and we look up here. Oh, 84 is the smallest, plus 90 is our largest. All we have to do is add those two numbers and divide by 2. And what do we get? No, you didn't divide by 2. Or, I don't even know where you got the 129. Say it again. 87. So, John, did you push 84 plus 90 and then divide by 2? If you do that, you have to put these in parentheses because you have to add those first and then divide. Your calculator is going to play stupid on you. So you got to put in those parentheses. Yep. Careful how you put it in that calculator. All right, range. How do you find the range?
Biggest plus smallest.
Not plus. This is subtraction this time. So to find the range, it is the largest entry minus the smallest entry. So what is our largest number in here? 13. What is our smallest? 9. So you take 13 minus 9, and what do we get? 4. That's the range. Again, you can have your calculator help you out. You can have your calculator put these in. Actually, they're already in order. So, I mean, but if they were not in order, you could have your calculator put them in order for you. So there's range. Largest entry minus the smallest. You got it. Mid-range, you're going to add and then divide by 2. Range, you're going to subtract the 2. Okay? And last but not least, what's 4? So 33, we want to find the standard deviation. Now again, there is a formula for this, but you would be outside your mind to run your formula on this. That's just crazy. That's a lot of work. Let's just have our calculator do this for us. Okay? And so we're going to put in the 13 and the 9 into our calculator, and we're going to run those one variable statistics. So we go under our calculator, we're going to go under stat, and we're going to edit. So I'm going to clear out my list, clear, enter, and I'm just going to put 13, 9, 13, 9, and there are 4 of each of them. 13, 9, and 13, 9. And so where am I going to go to find my statistics? Stat, calculate, and the first guy. Now, which one of these do we want? The SX. The SX right here, this guy is your standard deviation. And it says it wants you to round to what?
Second decimal.
Second decimal, the nearest hundredth. 2.14, that's it, done. 2.14. Because the 8 says, hey 3, go up 1. Okay? So 2.14. Come on. 2.14. Let the calculator do that work. Okay? We expect you to use a calculator. We do not expect you to do this by hand. All right, rounding this out. Almost done. So it says the scores on a test are normally distributed with a mean of 30 and a standard deviation of 6. What is the score that is one standard deviation above the mean? So remember when we talked about this, I gave you a little formula in class. You're going to take your mean and you will either add or subtract whatever number they want times your standard deviation. Okay? The adding or subtracting. You will add when they want above the mean. You will subtract when you want to be below the mean. So you will add when it is all about being above. You will subtract when it is all about being below. So let's start filling in what we know. Do we know what the mean is? It is 30. So it's above, absolutely. So that's the plus. That was our mean. So the number they want is 1. And then what's the standard deviation? 6. All right. So this is our formula we're filling in. Okay? We will add when it says to be above. We will subtract when it says to be below. You just have to read your problem and fill in the numbers. So, X bar. What are you doing? X bar means the mean. So when you read, it says we have a mean of 30. That's why the 30 is there. Because the problem says above, because it says above, we're going to add. This number right there is the number that they want. How many standard deviations do you want to go? We want to go 1 standard deviation. That's why the 1 is there. And then we're going to multiply that by what the standard deviation is. It says there's a standard deviation of 6. That's where the 6 came from. All you do is you do your multiplying and then add 30, which in the end, Brandon, you said gives us what? 36. So that is a score of 1 standard deviation above the mean. We're going to do another problem just like this. Okay? So the next problem says, scores on a test are normally distributed with a mean of 60 and a standard deviation of 12. What is the score that is 1 standard deviation above the mean? So, what's the mean? 60. So that's X bar. What is, are we going to add or subtract? Add. How'd you know?
Because it is
Above. So we're going to add. What's the number they want us to use? The 1. Because we want to be 1 standard deviation. And we're going to multiply that by, what is the standard deviation? 12. 72. Cool beans. Okay? So that is a score on this test, 1 standard deviation above. Excuse me. All right. So here they give us some information. And they give us a nice picture of this. In the end, they want to know what the percentage of buyers who paid between 19,000, and 23,000. So right down here below, they've given us all of our information of those that paid. So they want to know what is the percentage that paid from 19,000 to 23,000. How much is that? Yeah, 68%. You can see that percentage right here. Remember in class, we worked out a giant table of this. And you could also think about this as you remember that between each one of these middle bars, it was 34%. So you could take 34 plus 34 and get 68 as well, too. It's another way to do it. All right, 37. Same idea. This time, they want to know who paid between 17,500 and 19,000. So from here, 17,500 to 19,000. So it's half of 997, and what'd you get? 49.85. He just said it was half of 99.7. The other way that I showed you in class, remember I said we figured out each one of these guys. This was 34%. How much was this small bar? Nope. This was the 2.35. So 13.5? Yeah. And so you could add all these up, and that will give you the 49.85. Remember, I gave you this information in class about the normal distribution. We figured that out. So there are two thinkings to this. You can take 99.7 and cut it in half. Or, if you know what happens between each bar, add it all up. Okay? Number 38 is going to be just like this, although they're not giving you the picture. You need to make your own picture. What's up, John? Did you take the 2.35 and add it with the 13.5 and add it with the 34? Because those are the percentages we're dealing with. You got to add those up. Or, again, like what we said, take half of that number because you're dealing with half of it. Okay? Divided by 2. And that'll give you the same number. Two ways to think about it. All right. So this one, it says on the GRE, are normally distributed with a mean of 594 and a standard deviation of 121. Use the 68, 95, 99.7 rule to find the percentage of people taking the test who scored between 352 and 836. You need to make a picture of this. Make that normal distribution. Who did I tell you goes in the middle? Zero. Well, it's 0 because you're 0 standard deviations, but who's in the middle? The mean. So 594 is right here. The mean is in the middle of your standard, or excuse me, your normal distribution. Okay? So if I go here, how far above the mean am I? 1 standard deviation. So what is the test score here? We're going to take 594 and do what? Add 121 to it because we're going above. 594 plus 121. What do you get? 715. So we want to know what the percentage between 352 and 836. So we got to keep going then. 715 is not large enough. How far am I away from the mean now? 2. So we're going to take that 715 and, or excuse me, we're going to take the mean of 594 and add what to it? 2 deviations. 2 times 121. These are those problems that we did back on 34 and 35. So what does that give us? That's the 836. So there's our top piece. This is where we want to be at on the top side. Now all we're going to do is we're going to reverse it. Excuse me. Oh, excuse me. Thank you. So where am I there? Below, right? By 1. So we're going to take 594 and do what to it? 594 and do what? Minus 121, which is 473. We're 1 standard deviation below, so that's why we're subtracting the 121, because we are going below by 1. But again, that's not low enough. I need to be 352. So where am I at now? I am 2 below. So what am I going to do with 594? What am I going to do with that 594? Subtract what? 2 121s, because I am 2 standard deviations below. So what is 594 minus, say it again, 352. So now I know where I need to be below. So their question wants to know, what's the percentage there? And it's 95. It's 95. Again, how do we know that? Because we know this is 34%. This is 34%. This is 13.5%. This is 13.5%. So you can add all those up and you get 95. Or again, we're using this rule. The 68, 95, 99.7. When you're 1 standard deviations below and above, you're 68. When you're 2 standard deviations below and above, you're 95. Any questions on that one? It's just like the previous 2 problems, except they didn't give you the picture this time. They didn't give you the picture. All right, 39. So they want you to find a z-score for both these last problems. What is the formula for finding the z-score? These last 2 problems are all about finding the z-score. How do we do that?
Well, we find what the standard deviation is subtraction-wise, and find what that is relative to where you subtract the ones they got there, and then you divide that by that.
That's a lot of divide this by that and that by that. What's the formula, though? All right, so the data entry minus the mean, all of this divided by standard deviation. So you want to find the z-score? That's all you have to do. So what is our data entry? 62. So it'll be 62 minus, what's the mean? 70. Divided by, what's your standard deviation? 9. And they will want you rounding to the nearest hundredth. Rounding to the nearest hundredth. Rounding to the nearest hundredth. What do you get? Say it again. 90. Negative 0.89. You got to watch what you're doing. You got to look at that third digit, and that third digit tells the second one what to do. So again, and did you say 90? That means you did the same mistake that you did earlier, John. You got to use parentheses, bud, or use the fraction key. If you just use the fraction key, it will kick everything out for you. So what was our 62 minus 70 all over, what was the bottom, 6? Or was it 9? 9. So take negative 8 divided by 9. There's our guy. So John, what you did was this. And you can't do this. Or you did something along those lines. Oh, well, that's not 90, silly. Yeah. But again, it's not 90, though. It's point. Okay? Just be careful. Just be careful, John. Okay? It's a decimal answer. All right. Number 40 is going to be just like this. We're going to run that same formula. So we want to find the z-score of 16. So what's our data entry? No. What's your data entry? Nope. That's a scale. 16. Right here at the very end. 16. Minus, what's the mean? 11. Divided by, what is the standard deviation? 4. So you go in, you put this in your calculator, and you round to the nearest hundredth. And what do you get? 1.25. And that's it. And there you go, skis. That's what you need to know for your final in college mathematics. Chapter 11 and Chapter 12. If we didn't discuss it, it ain't on there.